Question 19 asks us to prove this identity, which says that cotangent theta over sine theta minus cosecant theta equals negative secant theta. And so what we want to do with these types of questions is to pick one side of this equation and try to make it look like the other side of the equation through algebra and through using our trigonometric identities. And so that proves that this equation is really true. When doing this, we can really pick either side of the equation to start with, to start working with. You just want to pick whichever equation looks easier to work with, and the one that you can see that there's more things you can do to it to change how it looks. So in this case, I think I'm going to work with the left side of the equation. And so I'm just going to write it here. So I have the left side equals cotangent theta over sine theta minus cosecant theta. And on my right side, I have negative secant theta. So I want to work with this expression here until I get negative secant theta, and that's going to make that's going to prove that these two sides of the equation are equal to each other. So to start out with, the first thing I'm going to do is change cotangent theta and cosecant theta to their sine and cos forms. So if we remember, cotangent theta is equal to cos theta over sine theta. So I can rewrite it like that. On the bottom of the fraction, I have sine theta, cosecant theta, we can rewrite as 1 over sine theta. Like that. Okay, and so the next thing I want to do is multiply this fraction by sine theta over sine theta. That's just equal to 1, so it doesn't change this expression and the value of this expression any, but what it's going to do is enable us to get rid of these sine thetas on the bottom of our fractions within a fraction. So that's going to simplify this quite a bit. And so when we multiply this sine theta into the top of the fraction, it gets rid of this sine theta on the bottom of this little fraction here, and we're left with cos theta. And when we multiply it into the bottom of the fraction, we get a sine squared theta minus, when we multiply it to this term, it gets rid of the sine theta, and we're left with 1. So it's sine squared theta minus 1 on the bottom. And so the next step, what we want to do is use one of our identities on our formula sheet, and that is the Pythagorean identity. So I'm going to rewrite that here in this space. The Pythagorean identity says that sine squared theta plus cos squared theta equals 1. And so if we rearrange this a little bit, if we bring the cos squared theta over to the right side of the equation, and we also bring this 1 over to the left side of the equation, oops, sorry, mess that up. It's going to be sine squared theta minus 1 on the left side equals a negative cos squared theta. And so now we can see if sine squared theta minus 1 equals negative cos squared theta, we can replace the bottom of this fraction here with negative cos squared theta. So let's do that. This gives us cos theta over negative cos squared theta. And so of course, on the bottom of this fraction, we just have negative cos theta times cos theta. And so we can cross out these cos thetas here, they cancel out. We're left with a 1 over negative cos squared, or sorry, just cos theta here. Okay, and if you remember, 1 over cos theta is the same as secant of theta. So this can be rewritten as negative, because we still have the negative here, secant theta. And we have a negative secant theta on the left side, which is the same as the negative secant theta on the right side. So we have proven that this identity is true.